Our next speaker is Fernando Hönig. He's talking about the new data center service model, Cloud plus DevOps. Have fun.
Thank you. Thank you all for coming to this talk. Really very thankful for NETWAYS for hosting this conference and for inviting me to present this thing. The idea of the presentation is to talk a little bit about how as you already know, the world is changing about cloud computing and changing from physical devices or servers to what we call the cloud. And also how the DevOps becomes integrated into this change. Some of the things that I will be talking here, probably you already know. But the thing is, I would like to probably remind you what are we doing and probably share with you and you share with the rest and also with me. Probably pain points that you are facing day to day and with this DevOps and the cloud. Something about me, I have almost 10 years of experience, mostly on the ops than the dev. Moved from Argentina, moved to London 3 months ago, and working for Rackspace in the UK. Previously worked for companies like Intel, IBM, and HP. On the last 2 years, 2.5 years, mostly dedicated with to monitoring systems, playing with Nagios, Zynga. So basically, that's my background. So as I told before, the idea is how we can switch from this, that is a mess, and probably data center is not a mess like this, but I do remember waking me up at 3 a.m. in the morning and going to a data center to change a disk or format a machine. And it seems that it's already changing right now, and we are now executing some API call to get a new server or get a new system installed. So this is basically what our minds needs to get used to. The cloud is not touchable, it's not feasible. We are not seeing what the rest of the people that is in the data center doing, but we have also our application running and running fine. So just a question, how many of you are in the cloud? Totally in the cloud? 100% in the cloud? 1. Perfect. Probably because you know that your application is for the cloud. And that's what I'm trying to say here on some myths about the cloud. Probably most of you are not in the cloud because it's not secure. Well, the truth is that the public cloud is a multi-tenant. So you're sharing resources with other customers and potentially could have some nice neighbors. And they can, I don't know, maybe give you problems with the networking or some high I/O or whatever. So the way to remediate this or to alleviate this is you can have an on-premise cloud. You can run your own cloud servers. You can have a virtual private cloud on a hosting company. Or you can have a hybrid cloud. For those people who didn't raise the hand when I ask about cloud, who's in the cloud, probably you can have some data on a physical servers and some others on the cloud. It's too complex. Well, there are different types of cloud with different levels of complexity. So for me, the remediation for this is just choose a cloud provider who can offer you tools and the support for the tools that they're offering. I know you, but in my first beginnings with cloud computing and cloud companies, the first time was very difficult to understand how can I provision a server and then get the disk and the monitoring and database or whatever. So probably you need to check out and what provider can give you tools and the support. And the cloud is for everything. For me, it's not. The truth is that not all applications are suitable for cloud computing. And probably because of the architecture of your application, or because the data that you're putting on your that you're storing on your application could be public-facing. No matter what about security, thing is, these are shared resources. Your disk is shared with other tenant. So probably you need to get better performance or control of your servers. So cloud is not for everything. Let's think about some scenario here. Let's say I don't know, web application, and the green line is basically your physical servers. I mean, you're doing a planning and you say, okay, this month I will put another server. Okay, thing is, between the yellow line and the green line, you're losing customers. And between the yellow and the green on the second, you are losing money, basically. So this is where the cloud can help you on not losing money and not losing customers. So in order to move to the cloud, you need to be ready. You need to understand and planify what exactly needs to be done for a success. It's complicated at some point when you just think on the cloud and say, hey, I'm moving to the cloud. OK, perfect. Tomorrow I will put some servers, move the code. Perfect. I'm in the cloud. It's not as simple as that. You need to understand what I've been saying before about security, about where your data is going to be stored, about the I/O. So this is when the DevOps comes in. So the idea of talking of cloud a little bit and the DevOps is to focus on how can we automate everything, how can we use some configuration management tools, how can we merge our ops code with our dev code into one single lane and work together between ops and dev. How can we test? And basically, how are we saving money, time, and value for the company? So automate your servers. Treat your servers as commodities. Basically, no server should be special. And by this is, you should not have servers with names, with Troy the Skywalker backup, or one monitoring 02, whatever. The idea is that you can spin up or spin down servers based on capacity or needs, but you might be able to remove a server with zero consequences for your business, for your application, for your uptime, whatever. So how many of you use configuration management tools? Oh, that's a lot. Perfect. So the idea of using these tools is that you can create exactly what you need based on a role that you're needing for your application. And the good thing is you can maintain state. So if something is being broken for some reason, you can just execute it again, and you will have the same result on the server. So you can execute the same recipe or manifest on 100 servers, and you should have the same state for all of them. Tools like Puppet, Chef, Ansible, or SaltStack could help on this. So for the ones that are not very familiar with this, let me try to wrap up a little bit. So you have a Chef server with your node objects and cookbooks, that basically the recipes that you need to execute on your virtual cloud or physical servers. You have an agent on each of those, and they're executing what the Chef server is telling to execute. So how many of you use continuous integration tools? Oh, less than the other. OK. The thing is, with continuous integration tools, you are trying to integrate as a team with the development, or the development with the operations team. Your server code, but your package, you're installing Apache, MySQL, MongoDB, whatever. It's a code, and you need to integrate that code with the application. So based on the release 2.0, the development team says, hey, I need to improve the performance on the Apache server. OK, sounds good. Perfect. What you should do as an operations team, basically you need to write something on your cookbook or manifest to improve the performance of the Apache. So you need to be on sync with the application team at some point to integrate their changes with yours. So you need to create the same development lifecycle. And as I said, the server code is also an application. You have, let's say, a database server. So that's basically an application. Database server, it's an application. What I'm meaning by development lifecycle is that your code needs to be passing through all the stages from, staging, testing, UAT, and production. So what is all of this if we can't measure about money, time, or value for the organization? About money, no need to buy expensive tools. We know that there are a lot of tools in the open source community that can help us to achieve this. Certainly, we don't want deployment nights or weekends. And the idea is that with this kind of integration and automation tools, there is no need to stay overnight to doing a deployment. And better than that is stop having outages. About time, it will speed up our deployment cycle, basically because we don't need to wait for some specific day to deploy something. We just push our code, it's being tested, it's being pushed to production. And the value is that your code becomes an enterprise code because it's being tested on all your environments. And the good thing is there is a common goal across the organization. Between your development team and your operations team, they both wants to be, let's say, an enterprise code. So for this, the bad thing is that we need to change. We need to change on our mindset. We need to change on, well, as I said, I'm an ops, and I hate devs. And the devs, I think they hate ops, because they're always fighting about whose responsibility when something is not right. So in this proposal of change, it's more like, OK, let's work together, find our pain points together and try to solve together. So it's basically a culture and a work methodology that we need to change or adopt. And we have the tools for doing this: the configuration management, the code management, testing, and monitoring. This is a really interesting phrase that I've been reading, and we've always done it this way. And I remember a company we've been working before, and they don't want to change their monitoring tool because they used to work always with this specific proprietary tool. And then I had to create all the infrastructure, let's say copy all the servers, and then show them, hey, this is being done with open source tools, and we are not paying anything for this. Oh, really? Okay, sounds interesting now. How we support? Well, we have a community that is helping us, and we can also provide some patches or whatever to what are we seeing? So they realized that there could be a change, that you can change, and there's nothing pure or that needs to be done like forever on this way. Right now, we have all this DevOps and cloud, and I really don't think it's going to last forever. Probably for our age, it's going to be enough, but probably for our son or more, it's not going to be there. So right now, I think it's a time for change, and I think we are ready to do it. How many of you know what is Kanban? Do you use Kanban? 2? Okay, perfect. The idea is about Kanban or Scrum or whatever agile methodology that you implement on your company is that both teams, dev and ops, can be integrated on a same methodology and try to understand what is the other doing and why it's not responding so quickly. So let's say the development team always wants things for yesterday. They want to deploy their code now. And sometimes you need to do some analysis on the infrastructure that's being deployed for the application. Or probably your ops team is not big enough to support the development team or development lifecycle. So with Kanban, you can show them that there is no, let's say, as an ops, we don't want to delay their deployment lifecycle. We just want to help them to deploy their application, and probably they need to help us to do the deployment. So with Agile, what we can do is basically release early, release often, and release several times a day. And using CI and CD, that we'll explain a little bit later, that ensures quality on our code. As a DevOps, we have a lot of tools. In fact, a lot. So thing is how we can combine all these tools and try to make like a rail of what is specifically needed for something. So I try to put in groups of configuration management, code management, automated workflows, or monitoring, and basically what it's for. So what I can say is probably the tools that I have on config management, it's basically on the flavor. I mean, most of you, I think you use Puppet. some others use Chef, some others use SaltStack, and the same thing for the automated workflows. It's basically on the needs of each company. I mean, there is no such as one specific tool for something. Same thing with code management. So at Rackspace, we choose to use these tools. Probably we can change in the future. I mean, right now, we are supporting this tool for our customers, and that's basically what we're doing. So let me talk a little bit about CI and CD. If you have any questions so far, just let me know. So what is CI and what is CD? How many of you use both, let's say CI and CD? 1, 2, 3, perfect, 4. Let's talk a little bit about how do I go faster, because that's a main problem of IT. I mean, I want the server now, I want my application deployed now, I want my firewall rule applied now. So how I do go faster on my deployment lifecycle. So as the competition is really unrelenting and the customer expectation is pretty high, on the traditional release approach, we're just deploying once a while, but on that time, my competition, it's basically ahead of me. So what I need to do is transform all these stairs in a single line, really next to the customer expectation. And that is when CI and CD becomes really important, because I will have my test automated and my deployment automated. So as a comment, I would like to say, if you write it, test it. How many of you, well, probably if you're using Puppet, how many, I mean, you're writing your manifest. You're testing your manifest. If the manifest is saying install Apache, are you ensuring that Apache's service is being installed, it's running, whatever? How many of you do that? 2, 3, 4, perfect, good boys. So that's the idea on testing. I mean, and also, how many of you are checking that the code that you are doing on Puppet, it's basically a compliant. I mean, it's compliance. It has the same, I forgot the word, structure or using common language. How many of you are doing that? 1, perfect. From the whole room, only 1 is checking that the code that it's writing is basically a common way to write a Puppet manifest. So what I'm meaning with you write it, you need to test it, is it is really important for the rest of the organization that you can prove that your code is tested, because at some point we'll give you, let's say, happiness or being really calmed down when a problem arises. So, and you can just rely on because there's another problem and not your code that you're writing. So the good thing about continuous integration is that gives you an assurance and good behaviors. This picture is nice. So you need to really pass your code from stage or from even your laptops to stage, test, make some integration with the development code, and also test on production. For the ones that they're not familiar with Jenkins, it's basically this the dashboard, and you have the status on the left, then name of the project, last failure, last success, last duration. The good thing about Jenkins, if you're not familiar with, is that you can execute several things. I can talk by chef because I'm doing chef. So basically I'm doing chef spec, I'm doing food critic, I'm doing test kitchen on the same Jenkins test. So what I'm sure is when I put in a code on the on Jenkins, is that my code is being deployed in a server, and I have a test that is being run on the server to validate that my code is basically running and it's doing what I'm expected to do. So continuous integration is basically try to merge the test merge the code that you're doing with some other coworkers and test your test and test the test of your coworker together in order to have a single piece of code that is being tested. So some idea of how it works. We have here 3 lanes. Let's say the green lane is the master, and then we have several branches, and the branches are several people that are working on different, let's say, features or changes. So this is basically how it works, and when you define a way to do this, you can just execute once you need. Basically, you have all on your green lane, you have the points. Basically, it's a release or a point of release. Of release. So the continuous deployment, it's known as CD. It's an optional extension to CI. I mean, there are no mutually. I mean, you don't need to have both. I highly recommend to have both. And basically, once a piece of code has been through CI, it releases automatically. And it's very useful for bugs on minor changes. And if you're using XYZ deployment for your version, you can just Y and Z pass through CI and CD automatically, and you deploy. So imagine how these companies are doing their, let's say Google, more than 100 releases per day. So it's going to be like impossible to maintain a code that is not being tested and with a continuous deployment lifecycle. So same thing with, well, Facebook or let's say. Have you thought how much does an outage cost in your company? Do you have some numbers? Do you want to share? I'm not going to ask what the company is because I really don't know. But I used to work with in a company before. The minute was 100,000 per minute. And they didn't have all this DevOps and automation and nothing, just basically servers in a data center, and sometimes this got full, outage. So it's really important to monitor your servers and also to understand how to recover from that. So the question is now, how do you eat an elephant? It's going to be complicated. So, yeah, perfect. So, about putting DevOps in your company or automating everything is not just I'm walk out this room and I'm going to automate everything. Now I know how to do it. It's basically planning and implementing and supporting. The planning could take weeks, months, and also the implementing, because I would say do not try to implement everything in one go. I would say just try to start with the easiest part, try to get involved with this kind of collaboration between your development and operations. And I think it's just, as I said, a culture change, and you basically need to start in small pieces and convince also upper management is not an easy task. After all, of course, automate everything. Try to not leave some things on manual, because at some point will wake you up at the 3 a.m. in the morning. Also plan to fail. Everything is not going to be as expected. So get a plan B, try to know how can we move quickly if something got wrong. So try to do this plan B structure on your mind, on paper. DevOps teams spend more time improving things and less time fixing things. That's basically the idea of moving away from the normal ops and dev. Because dev team basically works from Monday to Friday, 8 to 5 or 9 to 6, and then go home. Probably they will do some extra time on some days, but not normal. Ops team works from Monday to Friday, 9 to 6, and the rest of the week too, trying to solve problems. So I think if I work Monday to Friday, 9 to 6, I'll be able to do things that will save time on the weekends or even at nights, and can spend more time with my family, watching movies, whatever. So it's just a matter of trying to understand what needs to be done on your work time to have your free time really free. I have a story with this, because I used to have a manager that was saying, I recognize the guy who's not in front of the computer all day, because it seems that he automate everything, and now it's basically playing video games. And I really push hard to the people that is every day on the computer and solving things, because basically it's doing the same thing every day. It's solving the same problem every day, and that's basically I'm just throwing money on a box. DevOps team recover from failures faster, and that's because you know how much your code is being tested, or basically where is the problem, basically. You know that at some point could be a failure, yes, but you know that to recover from that point, it's really easy, or it's not, probably not easy, but it's faster than the whole process. The DevOps teams release applications more than twice as fast because they have the tools, not because they are smarter guys. They have the tools to do it. So I'm not saying please become a DevOps. What I'm saying is try to adopt some things that you've seen here in order to work in a really fast-paced environment and try to go home at 6 p.m. every day and understand that things could be automated in order to solve lives. I would like to show now a video that will try to summarize a little bit what is all of DevOps thing. So let's start it.
Meet Dave. Dave works for a company whose success is dependent on its ability to offer new and exciting products to its online customers, faster than its competitors. Dave is a developer who writes code for new products, new features, security updates, and bug fixes. Unfortunately, Dave needs to wait weeks for his work to be placed into production. This delay increases the pressure of staying competitive because some competitors are able to deploy new products and features much faster. In addition, this delay makes it very challenging for Dave to manage both the code that is pending to be pushed into production and the development of the next feature that he is responsible for producing. When Dave's code is finally deployed into the production environment, occasionally unforeseen errors or problems occur. This mostly happens because Dave is focused on writing code for his development environment, and it's not identical to the production environment. Meet Dave's coworker Anna. Anna is a system administrator from the operations team. She is responsible for maintaining and assuring the uptime of the production environment. The number of servers that she needs to administer is constantly growing because her company continues to launch new products and customers are consuming more of their services. This increase of servers has caused some challenges for Anna. The tools that she used to administer a few servers are not as effective when used to administer a much larger volume of servers. This challenge affects how new code is deployed in her production environment. Usually, when new code is released, it takes a little massaging to fit into the production environment. This is why she requires code deployments to be scheduled and are only allowed once a month. Once new code is actually deployed, it's her responsibility to diagnose any errors or problems caused by these changes. Sometimes Anna feels as though the developers have tossed their work over the wall to her and her team. So, what can be done to help Dave and Anna work better? Ultimately, they want the same thing: happy customers. What if Dave the developer and Anna from operations worked better together, thought more alike, broke down silos, shared responsibilities? This would require them to change their mindset on how dev and ops work. So what is DevOps? DevOps integrates developers and operations teams in order to improve collaboration and productivity by automating infrastructure, automating workflows, and by continuously measuring application performance. If Anna and Dave's teams were more DevOps oriented, they would do a few things differently. They would place more focus on automation. DevOps teams try to automate everything, from testing of new code to how infrastructure is provisioned. They would write software in small chunks that are integrated, tested, monitored, and deployed, usually in hours, versus the traditional way of writing large chunks of software over weeks or months, and then do weeks or months of testing. Plus, they will have identical development and production environments based on the same configurations. Writing small chunks of code will allow them to increase the frequency of deployments and improve the time to deploy new code. It also enables them to adopt an iterative process to monitor, measure, and improve the code and operations every day. Improve their ability to respond to market needs or other things that impact software. Instead of building and configuring software plus infrastructure manually on an ad hoc basis, Anna and Dave's teams would write configuration management code that describes how things should be built. As a result, they will have the ability to build infrastructure at scale, to dozens, hundreds, or even thousands of servers, in multiple locations, using different types of hardware. Another change that a DevOps-oriented team would do is to use a source control system to help manage, track, and document all of the changes to both the application code and configuration management code. The change that Anna and Dave would implement is to adopt a discipline of application performance monitoring and optimization in almost real time. This will allow Dave and the rest of his developers to understand the performance impact of their changes. The ultimate goal is to have a production environment that gives their customers a great experience. So what benefit does having a DevOps-oriented team give Anna and Dave's company? Well, it allows them to increase the rate of software delivery and improves the company's time to market, potentially from months and weeks to days and hours. This will be a huge competitive advantage. It also allows them to maintain better business focus by automating their infrastructure so that they can focus on things that improve the business and their online content. They will spend more time on these activities that add more value to their organizations. When a company is able to build and offer better products, this means they have happier customers and happier developers. How does a DevOps-oriented team actually accomplish this? Well, as mentioned before, there needs to be a change in the mindset of the two groups that need to work closer together. The other component to the formula is getting the right tools. New tools are needed in this fast-paced world. They will need a tool that allows them to build and test code continuously. An example of this is Jenkins. They will need a tool for source control, such as GitHub. This will allow them to manage, track, and document all the changes to their application code and their configuration management code. They will need tools for configuration management, such as Chef, Puppet, and SaltStack. These tools will allow them to deploy applications in an automated fashion, maybe across hundreds or thousands of servers in different locations. They will also need new tools that allow them to continuously measure the performance of their environment and application. Generating, reading, and analyzing system logs is extremely helpful to monitor an environment. But now that many environments have hundreds or thousands of servers, new tools like New Relic are required to make sense of all this data. This will allow them to know how the entire application is performing and help them identify bottlenecks. But many companies don't know how to use these tools or do not have the skills to automate software delivery process. In conclusion, DevOps is a new philosophy that can help software organizations innovate faster and be more responsive to business needs. It promotes collaboration between developers and operations, which improves quality of software development and more frequent software releases. Adopting the DevOps philosophy requires a new mindset, new tools, and new skills.
So, hope you are not sleeping. Basically, the idea of the video is to summarize what I've been talking for the last 30 minutes and try to see if do you think you're identified with this, or how far are you or in your company with this. That's basically all that I have. If you have any questions, if you want to share something, I'm happy to listen to you.
Is this video available publicly?
Yes, I just stream all the commercial parts because basically I don't want to sell you anything, but it's available on Rackspace. Yep.
How to get rid of the wall between the developers and the operators? So the software product comes from the developers and I have to deploy it. Often developers are not there and the deployment plans are lousy or so even not there. Are the developers writing Puppet manifests or cookbook resize or do I have to develop this for the developers?
Well, the question is how do we break silos between dev and ops, and how do we integrate? This is like a pyramid. I mean, upper management needs to be in sync with this culture change. I mean, probably the most important thing is to share objectives. And let's say, okay, now we are releasing every 2 months. Okay, let's try to put on 1 month. How can we do it? How can ops team can help dev team? Because on the dev team, probably there's an architect. And on the ops team, probably there's an architect too. So they need to work together to validate what is needed for next release. I mean, they need to plan. They need to make some teams that are fulfilled by ops and dev, and they need to work together. I mean, integrating ops people on an agile methodology, because probably the dev team is doing an agile. It's commonly they are doing agile. So, and ops not. Ops people is commonly not doing agile. Basically, seeing a ticket system and responding as fast as possible. So, integrate, for that reason I put Kanban, because Kanban could be integrated on Scrum and some others. So, and I've worked before with Kanban on a pure ops team, and help us a lot to, let's say, put that barrier away between ops and dev. So, in my opinion, upper management needs to be involved with this also. Yep.
How do you teach the skills to ops? I mean, for devs, code management and all this stuff is natural today, but for the ops people, this is new.
Yes, it is. In fact, as I said, I'm an ops. I'm trying to become a dev, to be a DevOps. But I think you realize this when you automate things and you're not waking up at 3 a.m. in the morning anymore. So when you understand that working together with the development team and that you're providing more value to the company or to the organization doing this, I mean, when you see the, let's say, the metrics about, okay, this application is performing well, how can we just performing better? Okay, how can I help to that? How can I work with the development team? Okay, you're doing this code. Okay, please test it. I will do the same thing on the application, I mean, the server applications, like Apache, MySQL, whatever, to combine both work in order to make it better. So the idea is, as I said, try to work together on get a better performance or results on your application or your company needs. Any other? Okay. Thank you very much for being here. I have a few T-shirts here to share, so if you want to just please come here. Thank you. Have a good lunch.